Hello and welcome to the latest in CDE's Engineering Insights webinar series. I'd like to thank you all for joining us today. While we wait for a few people to dial in and join us, I just want to quickly take you through the webinar platform that we'll be using for today's virtual tour. My name is Niall Toner and I'm part of the marketing team here at CDE. And I'm joined today by my colleague Lauren McMaster and Fergal Campbell, who will be presenting the tour. So the platform we use for this virtual tour is a system called Big Marker. And just to give an idea of how you can use it as we go through the tour today, to the right-hand side of your screen, you should see a chat panel. We encourage you to ask questions as Fergal goes through the tour. Any questions you have for Fergal, he'll do his best to answer them in the allocated time. If we run out of time, we'll obviously try and pick up after the webinar. You'll also see a Q&A tab. If you wish to use that to ask your questions directly, you can also do that. I'd also like to draw your attention to the handout section at the top right, where you can download some of the brochures from some of the equipment that Fergal will be discussing in today's virtual tour. So just in terms of the agenda for today's tour, Fergal will take you through the Kiely Bros site. And then, as we say, we've set aside time at the end for questions. So we do encourage you to put your questions to Fergal, and we have time set aside at the end. So the presenter today is Fergal Campbell, who is a business development manager for the CDE team in the UK. Fergal primarily looks after our activities in Scotland and has an extensive experience in the waste recycling and washing industry. So I'll now pass over to Fergal, who will kick off today's webinar by discussing the importance of recycling trommel fines.
Good morning. Thanks for that, Niall. As Niall introduced there, my name is Fergal Campbell. I'm Business Development Manager for CDE. Today we're going to look at trommel fines and why wash them. At its core, we're looking at recycling and essentially upcycling the materials that we've generally seen as waste. So trommel fines, for everyone I'm sure knows quite well, is a mechanically treated waste, residue from skip waste, which can't be treated effectively in the dry process. Generally a waste code of 1912-12. Looking just ahead of this morning, I noticed a note from the Environment Agency, the EA, where a study discovered that 57% of 50 samples of trommel fines destined for disposal were misdescribed in a report they done. And I suppose the basis of that is the difference between the lower and the higher rate landfill tax. There's a saving of over £90 per tonne there, depending on how people are looking at that material and wanting to reuse it or rebrand it. The core element of trommel fines that we see is that there's a high percentage of recoverable material in there. So rather than put it to landfill, which is a finite resource, there's only so many holes in the ground people can fill, and there's a lot of questions. Is that the right thing to do? We can recover 80% of that material for reuse in construction and other uses. So if we're looking at it from a perspective of humans on the planet, we're saying that the number of people living in urban areas has quadrupled since 1950. And the United Nations predicts another 2.5 billion will join them in the next 3 decades, which is the equivalent of adding 8 cities the size of New York every single year. So in order to build that, you need a lot of sand and a lot of aggregate. So from CDE's perspective, it doesn't make much sense to put sand and aggregates into the ground as waste when they can be recovered and reused properly. So that's sort of the background of why we recycle trommel fines and why we think it's a valuable material to recycle. Now we've got an overview of the Kiely's plant here, which we can see plan view. The plant's working at this stage. Obviously, you'll see from the stockpiles and the movement of the loaders there. From this point here, we'll move into the technical tour and the overview.
So here we are now, dropped into the Kiely Brothers site in Birmingham. I'm going to pass you over to Fergal now, who's going to take you on a guided tour of this washing facility.
Yes, so now we're looking at an overview of the plant here. So looking at the process from the start, this is a 30 tons per hour solution. So starting point is the feed hopper, which you can see to the bottom of the picture. And the feed hopper itself is being loaded with a loader on site with a variable speed. So the tonnage can be increased or decreased depending on quality and throughput required, and weight on a belt wear. So the feed hopper receives the material, offers initial oversized protection with the grid, and transfers that material to the feed conveyor. So due to the nature of the material, there's also an overband magnet on the conveyor to take out any ferrous material. And also one of the things you'll notice here as well is the covered conveyor. So that just allows for quite a dry material to be protected from crosswind so it's not blown around the site. Moving on to the next section, we can see here we've got the pre-screen. So the material enters the pre-screen, it's washed with spray bars, and the finer material washed through the screen while the larger material is retained. So I suppose just looking at this view gives us a few little added extra points to look at here. We've got the GRP walkways, which increased durability, better grip, lighter material, and the fully bolted handrails as well. So rather than key clamps, which can give way over time, a much more robust solution. So also we've got the roll and chute, so we can pull the feed chute out of the way if we want to get access to the Rotamax down here as well. And our infinity screens, trilogy wall design, fully bolted. So a lighter screen that's transferring the energy into the material rather than being used to lift the screen. So as I said, the material here is washed and the fines are washed off while the larger material makes its way into the log washer. So at this point, we've had that transfer of fines and larger. From here, we can see the log washer itself. So the Rotamax 80. At this point, we're using a lot of scrubbing and density separation. So the material enters, the shafts start to move the material. So it's material on material attrition, which is used to break up the material. And once that material's been given its initial attrition, an upward flow of water is used to float off lightweight materials. So we're taking off the lightweights, which are being transferred then to the next stage, and the heavy material has been retained and moved forward. And as that material is moved forward, it's scrubbed material on material. So the paddles and the shell of the Rotamax doesn't come into contact with moving material. There's a bed of material there to act as an extra wear liner, and that allows that energy to be moved into the materials for it to be broken up and separated. So with that, it's moved along, as I said, and it's moved on to the sizing screen here, whereby we can see materials are sized out and given a final wash so that they're clean products coming off from that material, and all the water is captured and returned back down to the dry sump here for the next stage of the process. So we can see a view here again. As I said, we've got the materials moving down from the rinsing screen and down to the dry screen here. So the lightweight material, they've been floated off at this stage and discharged onto the dry screen for dewatering and removal, stockpiled. So again, one of the key factors of this equipment is that all the water is retained, it's captured, it's moved through the next stages of the process to minimize any spillages or loss or anything like that. From this point, we've captured all our liquid material, and that includes our sands, silts, fibres, polystyrene, organic matter, and we're moving it across into the density separation stage. So here we've got the CDE CFCU. At this point, we've removed the large material, as we've said, and sized it, and we're left with all that smaller material, which is formed into a slurry. The slurry is then pumped to the CFCU where the discharge material enters the body, and it's met with a precisely controlled upward flow of water, which elevates the lighter materials up and over the weir, while the denser materials start to settle to the bottom. So this is something that we've used over the years very successfully in lots of different applications. And as we can see from the slide, we've got the CFCU here. So the heavy material is settling, as we said, and as it gets to the bottom, we retain a bed of material. So that's set up during the commissioning stage. So within the plant, it's a fully PLC controlled, and this is fine-tuned at commissioning stage, so it doesn't need adjustment on site by operators, but it does have the facility to do that. When that bed of sand is at its optimum level, it's released onto the sand stream where it's dewatered and stockpiled. And the lighter material is weired off the top of the CFCU and goes over a further screening stage, which allows that fibrous organic type material to be removed. Typical wash plants would retain that material within the sand, which obviously limits its quality and therefore the uses that are available for that sand. We see now we move into the water treatment stage. So Trommel fines, due to their nature, can produce a lot of fine material in the water fraction. And key to that is the introduction of water treatment using additives such as polymers to clean the water for reuse. And again, absolutely critical at this point is that can be done right or it can be done very wrong. Just adding chemicals isn't enough. It's understanding what you dose, when you dose, how you dose, and the stages between the dosing points all affect the quality of the water in the recycling stage, along with affecting how much it will cost per tonne, because if you get this stage of the treatment wrong, you can increase your costs significantly. And I suppose it's CDE's understanding of this over the years that gives us a unique advantage. From this chemical dosing stage, we move on to the aqua cycle. So at this point in time, we have dosed the chemicals. The settlement has started to occur. The material, as it enters the aqua cycle, moves to the middle of the aqua cycle. It's now quite heavy. It's binded together and drops out of suspension. That allows then the water to rise. As the water rises, there's always the probability of some lightweights moving with it. So we can see here on the plant the scum weir. This allows us to capture any of those little lightweights that are still retained within the process. And we've got a scum scraper here which circles round and drops these materials into this launder so they can be removed and isolated. The thickened sludge that has dropped to the bottom is monitored till we understand the bed depth of that sludge. Once we understand the bed depth, we then pump that sludge into the buffer tank, which is located just here. And that buffer tank is then agitated to keep the material in suspension and also to homogenize it because of Trommel fines and the variability that homogenizes it before it moves on to the next stage of the water treatment. And the next stage we can see here is the centrifuge decanter. This essentially works by running at high speed, 3,000 to 4,000 RPM, and pushing the heavy material to the outside walls, which is then conveyed out and discharged into a stackable product, while the water is retained and kept in the middle of the material so that it's then moving back into the treatment process and used again and again. Probably one of the things that we notice on the last slide that I didn't probably highlight too well here is as the water comes off the aqua cycle, it's passed over another static screen here to remove polystyrene. So you can see quite a lot of polystyrene is within Trommel fines, and anyone with experience of Trommel fines will be very aware of this material. And that's just an extra step to take those out, isolate them, and put them into a use that can be reused. And we can see here also we've got the control cabin. The control cabin's full PLC HMI, which has the CD Smart Tech included, so the operator can monitor the tonnage, start times, stop times, and a lot of our customers have used it very effectively. Not in a big brother sense, but from looking at how they can optimize their plant. So if they notice a trend, something happens at 9:30 every Tuesday, they can see, okay, well, what happens? How do we mitigate that? How do we keep our tonnage at its optimum throughout the operation of the plant? Also small things here, I suppose, attention to detail that you'll see on any CDE plant is lighting at various points here, life buoys for above water, and labelling of simple things, pipe work, so process. You can see it actually here with the control room. So everything's, I suppose, well thought out and well designed to make it its optimum. That's really the full overview of the plant. I hope you enjoyed it. Yeah. Apologies there. I managed to mute myself. As we've just introduced there, so that's an overview of the plant, and I suppose at this stage it's probably right to thank Kiely Bros for allowing us to do the virtual tour and trusting in CD to deliver the solution for them. Again, looking just at the plant itself, we can just see the four main output products there that are being created. So we've got a 0 to 2 mil fine sand, a 0 to 4 mil coarse sand, a 5 to 20 mil aggregate heavy material, and a 20 to 80. So those materials are all quality controlled and assessed and found uses for. And what we see here in this next slide is some of the quality of the sand that we can produce coming off Trommel fines processing on a fine sand. So you can see aesthetically it's excellent, and also from a quality perspective, which is more important, obviously, how clean it's got. And here we've got a few pictures of the materials. To our left, we've got the 5 to 20 aggregate. We've got a sharp sand, the 0 to 6, polystyrene third over, and a finer sand on the right hand side. So again, you can see even with the polystyrene how we can isolate that product out due to its characteristics and bring that to the point where it's almost, dare I say, reusable again, if such a thing exists, obviously. As the plants evolve and as this process moves on over time and we produce consistent quality results, customers will look for more and more outlets for these to look at. But again, just going back to something I kind of touched on earlier, really was the use of construction material and how much we need. People sometimes will say to us, oh, well, the sand or the aggregates, is it suitable for concrete making? Absolutely. There's a quality control there, and there's testing and everything that needs to be aligned with that. But if we look at concrete as a product, 50% of concrete that's used is less than 25 newtons, and 75% that's used is non-structural. So it gives you a sort of idea of the quantity of concrete that's needed. We're not saying, Trommel fine sand is going to be used for high-rise buildings. That's not what we're trying to get. But what we're trying to say is there's a lot of concrete and construction material needed that does not need to be virgin aggregates. And the carbon footprint goes with that. We were looking at stuff in Zurich and within Zurich and Switzerland, recycled materials are mandated to be used in road construction and maintenance. So the sub base, the foundation level, there's up to 30% of recycled concrete used. and for the road base up to 60% reclaimed asphalt is permitted to be used, and it can be up to 80% for sidewalks or places with low traffic. So again, we're looking at it from the perspective of there's a lot of opportunities there for recycled materials to be used and brought back around and brought back up the value chain, so that we're not sort of removing them from the process. We're retaining the value of the sand as it would be as its natural product. I think we've got through most of the key points there, I hope. I'll pass you back to Niall here.
Yep, no, thank you very much, Fergal. That was a very informative tour, and I see we've got a few questions now coming in, so we still have about 5 to 10 minutes here to run through a few questions. So we'll obviously try and get through as much as we can here, but if you do ask a question and we don't get time to cover it, Fergal or one of the other team representing CD in the UK will certainly be able to pick up with you after today's webinar. So just first, Fergal, a question has come in here from Jared. Asking about the pre-treatment. So is there any pre-treatment of the trommel fines before they go into the wash plant?
Yeah, so the fines are obviously they're coming from building commercial skip waste. So they are coming in through trommels, and generally in most trommel fines throughout, I suppose, the UK and further afield, we tend to see they're somewhere in the 8 to 16 mil range, depending on how fine people are trying to screen down. But that's sort of would be the standard. Beyond that, it's that dry material that's been brought to the plant.
Okay, very good. And another question here then from Ed, just asking about variability, particularly in clay, and how that is dealt with.
I suppose clay is a good question. With the clay, yes, there's a variability there. The reality is there's a variability in all the constituents of trommel fines. So we find, in some areas the clay content might be that little bit higher. In other areas you might find a little bit of organic contamination a bit higher. The plant's designed for that eventuality. So, people would say, do you need that sort of equipment for the fines? Well, yes, because you're dealing with the variability. So we need to have that scrubbing that is there for the worst case scenario. So we maybe hope for the best case scenario that the trommel fines come in exactly as we'd like to prescribe. But I think it's important just to always have the plant to have that headroom capacity to deal with that. So that additional scrubbing, the capacity of the machine is aligned for variability on soils or any other constituents.
Okay, and that's obviously a benefit of our modular washing equipment that we have here at CDE. Another question here then from Nick Fergal is looking at the weight of the trommel fines. What weight in cubic meters are the trommel fines, I presume, from this plant here?
Yeah, combined, you're talking somewhere in the region of sort of 1.4 to 1.6 tons per meters cubed. So you've got your lightweights there, which obviously, from a volume perspective, are massive. And the volume of polystyrene and lightweight constituents is huge. And visually looking at the product, you would think that there's potentially not a lot of sand or inert material within that. But because of obviously the density of that sand, it makes up a significant amount. We're seeing, in the region of 80% plus up to 90%.
Okay. Very good. And I see just we have another couple of questions here, so we should have time to squeeze them in. Question here from Keith. He's actually asked a couple of questions, but I think we can take the first one anyway. Fergal is looking at water within the plant and any contamination that builds up over times and how that may affect performance. Keith's just asking about top up water in a day for a given throughput.
Yeah. I suppose with contamination, there's always that, the duty of care of the source material. So you shouldn't be seeing that contamination coming in on that sort of material. Now it can happen. Obviously, we know that. The build up over time, we don't really find that. Our process is isolating out any of those contaminants and removing them. So we don't see that concentration. It's a question that gets asked of us a lot. The analysis doesn't, bear that out. There is occasions in plants we've done in the UK and further afield where that is the case. And again, with our modular type approach, we can add in additional items within that to deal with the contamination as and when it may occur.
Okay, very good. And then just, I think we might have time for one final question here before we finish up. We have a short video just to finish today's webinar. So just one final question here, talking about capacity. I think in a year, what's the maximum capacity of a plant on a single shift of, say, 2,000 hours, and the average percentage split between the 4 products?
Good question. The max capacity of the plant, you're talking, depending on what size of plant you want, really. There does become a point whereby it makes sense to not go any bigger. The capacity in general, we've seen systems that are down as low as 10 tons an hour, up to 60 tons per hour. And again, most people want to deal with their own problems or with the problems, the fines that are coming from their own processes or people that they've dealt with a long time, because they don't want to run that risk of, variable feeds coming in. So the capacity can be what you want it to be. All our plants are designed in-house, they're built in-house, they're commissioned, trained, supported. Everything's in-house in CDE. So we have that adaptability to design what you need. The split between the 4 products, your sand takes up the bulk of that material. You're talking in the range of sort of 60% by weight, sort of 20% on the aggregates, and then sort of roughly anywhere from 10 to 20% then on the fines and organics, and possibly even less sometimes, because, as I say, the nature of that material is it's actually, the density is quite low, so volume wise it may be quite a bit, but the weight is quite low. Okay, very good. Thanks for that, Virgil. We do have a couple more questions which I think we'll have to pick up sort of offline after the webinar, just conscious of everyone's time here this morning. And we're just going to finish off with a short video to finish today's webinar. So I guess before we go, I'd just like to thank everyone for dialing in and joining us. Thank Virgil for his time and taking us through the Kiely Bros wash plant. I hope those who joined us found it very useful and informative, and give you a bit more understanding of how Trommel fines can be recycled and how CDE can help you if you have such a challenge. So as I say, thank you once again for joining us. I'll pass over to Virgil for a final goodbye, and then I'll play a short video to finish today's session. But thank you very much for joining us. Yeah, likewise. Thanks everyone for joining. Thanks for the questions. Apologies if I didn't get to answer them all there. It's we're just I suppose bound by time as well. Again, I'd like to extend a thanks to Kiely Bros for allowing us around the plant and getting a look around and working with us on it. A great company to work with. My details are on the screen there if anyone wants to contact me, and more than happy to talk and see if we can help you in any way. Thank you.
We're here today at Kiely Bros site in the Borsley Green area of Birmingham. It's about a 6-acre site, and as you can see behind me, the CDE plant is processing Trommel fines material. Kiely's are the largest provider of surface dressing and microsurfacing in the UK, and they complete about 15 million square metres every year. Kiely's are also processing skip waste through a dry recycling system and a picking station close to this site in order to recover materials and divert those materials from landfill. What's coming out of that process is Trommel fines.
Kiely Bros approached CDE because they wanted to obtain a more sustainable future for their skip business and the waste stream that was coming from their skip business. That waste stream can consist of organics, woods, metals, and obviously a lot of earth and soils and sand and aggregates. Typically, Kiely Bros would produce up to 800 tonnes of this material per week, and that would all be going to landfill at great cost. As with all projects, the project started with an analysis of their feed material to see what materials could be recovered by a wet processing solution. Once we'd done that study on the material, we then looked at the technical aspects of the plant to separate the materials into the necessary fractions that would give the customer the necessary return on investment. We had to identify the correct site to locate the plant. We looked at a number of sites and eventually chose Cherrywood Road because it had an existing slab and good access for transport. It wasn't without its challenges because space is quite tight, and with it being in an urban setting, we had to consider local housing and planning constraints.
The facility can accept about 30 tonnes an hour of Trommel fine waste. That waste, as well as being diverted from landfill, is also then being turned into a variety of different sand and aggregate materials.
We're making a number of sands. In this case, we're making two sands, so a concrete sand and a building sand, so 0 to 2 and a 0 to 4 millimetre, and also a number of aggregate fractions. And they will be used in low-grade secondary aggregate applications, things like pipe bedding, fill for haul roads, etc. So complements the secondary aggregate market, which is a well-established market within the UK, represents up to about 20% of all aggregate used in the UK is from a secondary source at this stage, and I think Trommel finds it's on the next step of that journey. The major benefit for the customer since installing the plant is that they are now diverting 80% of that waste stream from landfill. The investment in the Trommel Fines plant represents the second investment from Kiely Bros in CDE technology. The first being a free flow unit, which is our mobile washing plant, which they use in their other business, which is for the road surfacing, where they recover surface dressing chippings and wash them to recover them and to reuse them on the road. That was the first of its type. For CDE, we designed that bespoke for Kiely Bros. It's since gone on to be sold elsewhere around the world as a CDE product. Having now completed a successful project for Kiely Bros, it sets CDE in good standing to deliver more Trommel Fines projects throughout the world. At CDE, we're excited about the impact our proven technology can have on the Trommel Fines waste problem. Recycling has to be the way forward for Trommel Fines through CDE proven technologies.